Another thing to note is that conduction in the respiratory system, for example, the trachea, is something that doesn't participate in gas exchange. So it's called anatomical dead space. And so another note is that at the base of the lung, the force of gravity will pull the lung down, and so it'll be a smaller intrapleural pressure compared to the apex of the lung. So what does all of that mean? So for example, you have the lung right here, right? And so at the top, the apex of the lung, you can see that, well, first of all, atmospheric pressure is around 760. And so over here, it's 753. And so you can see that compared to the base, it's 758, which is closer to 760. So what does this do, and why is that? Well, first of all, the lung pushes down because of gravity, right? Gravity's pulling down on the lung, and so it's going to squeeze this compartment. And so that means that there's less room here, and so it's going to be 758. So it's going to cause the intrapleural pressure to be less. The relative pressure, right? So that's why it's only 2 away from 760. Over here, since it's not as affected by gravity, right? So in regards to the cavity, it's going to have a bigger gradient. It's going to be 753. Now this actually does affect you, right, in the upright, and this is in the upright position because that's how gravity is going to affect you and cause this relatively low intrapleural pressure. And so this does cause an effect because right here, what happens is because there's less, right, there's only 2 away from the atmospheric pressure, it's going to allow it to be smaller, right, because it's a smaller gradient. And so when it's a smaller gradient, it will be, the alveoli will be smaller. And so because of that, it allows the lung, or it allows that alveoli to expand more. And so since it can expand more, it's more compliant, and therefore ventilation will be higher. Up here, since the gradient's higher, the alveoli will actually be expanded. So since they're already expanded, they will be less compliant. And so since they are less compliant, they can actually expand less. They can't expand as much as these guys, because this guy's going from a small balloon to a big balloon, but this is going from like a medium-sized balloon to a large balloon. Because of that small increase, it doesn't have as much surface area, and therefore it can't have as much ventilation. That's why ventilation is higher at the base, and the other thing is perfusion is higher at the base. And why is that? Because once again, since the right side of the heart is not as thick as the left side of the heart, it actually pumps with less pressure. Since it pumps with less pressure, it's going to end up, gravity is going to actually play a bigger role in drawing it down because the heart's playing a smaller part. So since gravity is playing a larger part and pulling that blood down, it's actually going to have higher perfusion down here. So that's the 2 takeaways I want you to remember, that there will be higher ventilation because of this compliance. Compliance is higher at the base because the alveoli are smaller because there's a smaller gradient. And then perfusion is higher because the right side of the heart is going to be weaker. It's relative to the left side, and therefore gravity is going to play a bigger part. And therefore it will end up causing a higher perfusion here. What's kind of confusing is the fact that even though both ventilation and perfusion are highest at the base, the VQ ratio is actually the highest at the apex. And I'll explain that in the next video. So I hope that helped, and thanks for watching.